Welcome to Geopolitical Horizons, a podcast from thegeopolity.com. Semiconductors are fast becoming the oil of the 21st century. They will allow us to get all the power and speed in things like smartphones, tablets, digital TVs, wireless communication infrastructure, and many other devices. The supply chain for semiconductors is critical, similar to how the supply of oil was critical in the 20th century. And that's why it's not surprising last year, US President Joe Biden, he placed an embargo on the export of advanced semiconductor chips and equipment to China. So here to make sense of the geopolitical semiconductors is Nadeem Aslam, who is from the industry. How are you doing, Nadeem?
I'm doing well, thanks.
So it's good to have you here, Nadeem. Let's jump straight in. And I think the best place to start, Nadeem, is for the benefit of our listeners. Let's start with some basics. What are semiconductors? How do they work? And why are they so important?
So basically, a semiconductor is what we'd term a microchip, and it's found in various devices, as you mentioned in the introduction: smartphones, tablets, digital TVs, network infrastructure, etc. And it has some transistors which control the electrical current, and this finds what your computer or your smartphone is doing, i.e. the software that you use on the computer, etc. is defined by these semiconductors.
So Nadeem, if these devices didn't have semiconductors, would they not work?
That's correct. If they didn't have semiconductors, then there's nothing to, as they say, compute what's occurring on the screen or in your software. So there's no calculation can take place.
Do your semiconductors do the calculations, or do your semiconductors, does that give the power to do the calculations?
Semiconductor, no, that might be one aspect, but semiconductor actually translates software. So it's ones and zeros, but they actually carry out the calculation, don't they, as well?
Right. So when they first used it in missiles, it was doing all the calculations, where you are, the terrain.
Yeah, so that's how they can, that's why they used it in missiles, so that they can pinpoint where they need to drop that weapon. So it's about calculation, so that's why it's called a central processing unit. Processes the information that's being given to it. Your original semiconductors might have been very simple semiconductors for a digital clock, which just tells you your time, but nowadays they need to be more advanced so that you can edit videos, watch videos in other technologies, i.e. in missiles, etc., so that they can make quick decisions on what the terrain is or where this weapon needs to land, that kind of thing.
So Nadeem, how have we got to where we are today with semiconductors? Who invented this technology? And, how has the industry evolved? And, as far as I know, I didn't hear of semiconductors when I was growing up. Is it something new, or have they been with us for a while?
So semiconductors have been around since the 60s, basically. So some people do think it's a new phenomena because of smartphones in your pocket, etc. But they've been around longer than you know. And in the 60s, they were actually developed for the US military and NASA, so that the US military could have guided missiles and NASA could carry out its moon landing with a guided spacecraft.
How have we got to where we are today, Nadeem? Who invented this tech, and how has the industry evolved?
So some people think that semiconductors are a new phenomenon, but actually they've been around since the 60s. It was invented by two American engineers at two different companies at that time, and it was developed because of the US military's need and NASA's need for guided missile systems and guiding the spacecraft to the moon, etc. So that was a starting point of semiconductors. In the early days, they were just transistors soldered onto a semiconductor material. Throughout the decades, they've now developed into where they're actually etched onto silicon wafers. And in the 70s, we were looking at the original semiconductors only had 4 transistors, and by the 70s, this was up to thousands. And in 1989, we were at 1 million transistors. So through the decades, the number of transistors has phenomenally increased. There's actually a law in semiconductors called Moore's Law, in which it states that the number of transistors will increase every 2 years, double each every 2 years.
All right, so that's 70s. What about 80s, 90s? Major developments there?
80s, it was just the number of switches on the silicon were just increasing, and 90s was when they hit the 1 million.
1 million. And what's happened like modern day? What are the major developments currently?
So currently we're standing at 134 billion transistors for a microchip, and that's the most powerful microchip that for a consumer product, at least at this moment in time.
And Nadeem, are there any like ceilings that we can't like? Will we be able to go above 100 billion? Like if we have the technology or we have the knowledge?
Well, the way that semiconductors are etched onto wafer, it uses laser technology, so it's dependent upon the physics. But at the moment, we're already on 5 nanometers in terms of these are the transistor sizes, and that's a nanometer is a billionth of a meter. So getting down to the numbers you're talking about, there may be a ceiling that we likely hit with silicon, and it may be that the industry needs to explore other materials to use or other ways of etching the transistors because it might be beyond the limits of the current laser technology.
So Nadeem, would it be correct to say some of the technology we're using currently wouldn't have been possible without semiconductors?
That's correct. So if we didn't have semiconductors, as I mentioned, we wouldn't even have the simplest of things like even microwave ovens that have a timer in them. It still have a semiconductor. It might be very simple and limited number of transistors, but there's still something that's controlling that. And then obviously, if you look at even the smartphones that we carry around with us today is thousands of times more powerful than the one that was used to actually carry out the moon landing. That's how far we've advanced in that time period.
Okay, so Nadeem, let's move on to the supply chain. Who makes these semiconductors? Where are they made? Who are the main players?
So historically, as I mentioned, the semiconductor industry started in America mainly, and historically, America designed, manufactured, assembled, and put into products these semiconductors. But then in the 70s, they moved some of their manufacturing to places like Japan and South Korea. But then this affected America's own semiconductor industry, and it was something that they felt they needed to address. So actually, Ronald Reagan in 1987 imposed on Japanese chips a 100% tariff, which made the Japanese chip more expensive to import into America and was more helpful to the American industry. In between that, obviously, other players came along because of the Japanese market crash in the semiconductor industry. Taiwan started bringing back some of its engineers from America by encouraging them to come and start companies of semiconductors within Taiwan itself. And this is where the biggest player in the semiconductor, TSMC, which is Taiwan Semiconductor Manufacturing Company, started in 1987 with 50% funding from the Taiwanese government.
Okay, so today, Nadeem, what's the structure of the industry? Because as far as I've read, the designs are separate to the manufacturing, and the machines aren't made by the manufacturers or the designers. So what's the structure of the industry?
Chip making itself, as you mentioned, it is actually segregated a bit now. So there's 3 types of chip makers, if we were to classify them. One is integrated device manufacturers. So they actually do the design and manufactures of the chips. So these are companies such as Intel and Samsung. Then you have another type of chip manufacturer, which is one that just fundamentally looks at manufacturing the chips, but the chip is designed by another company. So they're known as fabrication companies, or they call them foundries as well, sort of thing. So these are likes of TSM, Global Foundries, UMC, amongst many others. And then the third type of chip manufacturer is what they call fabless, i.e. they don't have any manufacturing capabilities themselves. All they do is design the chip and pass it on to these companies that have these fabrication plants. So they're companies such as Qualcomm, NVIDIA, AMD, and even Apple with its new M2 silicon, etc., is all based around being fabless.
Mm-hmm. So this is supply chain, Nadeem. How much of it does America dominate? What about Taiwan? Where is their dominance in the supply chain?
So in terms of countries for the supply chain, a semiconductor actually goes through a lot of air mile to become the final product. So generally, the US is a key player in terms of some of the manufacture of the equipment, the software, and the designs. And then you have Japan that actually makes the wafers and some of the chemicals required for the chips. So the wafers are the thing that your semiconductors are made from. So they're made out of silicon, but they come in like big rods. And these are manufactured generally in Japan. Then there's another key player, which is the Netherlands. And it's quite a surprising one. But they actually manufacture the equipment required to etch these transistors onto the wafers. So it's a company called ASML, Advanced Semiconductor Materials Lithography, and they're in a unique position in being the only company that manufactures the equipment to make the most advanced semiconductors, and even companies such as TSMC, Intel, Samsung are reliant on this company to supply the machinery to them for them to produce their chips or manufacture their chips. And then within Taiwan is a key player in that the most advanced chips manufactured around the world, Taiwan controls 92% of that manufacturing process. Yet they get the machines from this company in the Netherlands, but they manufacture 92% of these chips. And then the next biggest player, I suppose, or consumer, we could say, of the chips is China itself. So they actually take these chips, which have been designed, manufactured, assembled, and they actually put them into products that we use on a day-to-day basis.
Okay, so it's good you've touched on China. We can't really talk about semiconductors without talking about China. In fact, China and semiconductors have become completely linked together. So how did China become such an important player? What part of the supply chain does China dominate, or does she have influence over?
So China became a player in the semiconductor market in the 90s after the end of the Cold War. Prior to that, they were excluded because of various export controls. And it's at that same time that China was looking to become manufacturer for the global markets. And part of this involved placing chips that had been manufactured elsewhere, i.e. in Taiwan mainly, into products which were destined for consumers. So obviously when China became a big importer of microchips, utilizing over 40% of the world's produced chips, China realized in itself that it become too reliant on the US and Taiwan for its microchip supply. So this prompted China to look into creating its own semiconductor industry. So what China did is it wanted to drive forward with its semiconductor industry and sent people to learn knowledge from other countries. And what they did is also had people that were working for this company in the Netherlands called ASML, the one that manufactures this equipment to create semiconductors. And in 2012, Zhongchan Yu actually left ASML and set up two companies, one in China and one in the USA. And he recruited other ASML engineers to the US company, which was the start of the Chinese semiconductor industry, even though the espionage was denied by China, but ASML had indicated that espionage had taken place.
All right, so it's the age-old method of stealing the blueprints or getting the knowledge by hook or by crook. That's how China's managed to get to where she is now.
That's correct. And so what they've managed to do is, based on that, they've managed to develop some of the industry around not the most advanced chips, but the previous generation, which is based on deep ultraviolet lithography.
So I did read in this week that for the moment, China's not been able to make the advanced chips. So what needs to happen for them to overcome that challenge?
So for China to overcome that challenge, they really need to develop a machine equivalent to the cutting edge machine that's been developed by ASML, which is extreme ultraviolet lithography. But the problem...
For the benefit of our listeners, so what exactly is this machine? Sounds like some time machine. What is it exactly?
So it's just a machine that fires a laser at a silicon wafer, but it's in a vacuum, because that's why it's called extreme ultraviolet lithography, because the wavelengths that it's being done at, if it was done through air, they'd just get absorbed, and this is where the complicated physics comes into it. So they have to actually do it in a vacuum, so the particles are absorbed by the air.
Oh, okay, so this isn't it's not something you can copy and paste. This requires some very technical knowledge, trial and error. This ain't something you can just just pick up from somewhere and just do it.
That's correct. I mean, this machine in itself took ASML 20 years to develop. So it's not something you just watch a YouTube video about and you'd be able to copy.
Right. This machine, Nadeem, just speaking out loud, could I not just get it off the black market?
Well, the machine in itself is the size of a double-decker bus. And when it shipped in 50 cargo containers. So unless you can get 50 cargo containers from black market, it's going to be very difficult. And some of these components, there's thousands of components, and some of these components actually come from America itself. So it's not like you could pick these components up from one location alone.
So Nadeem, if China is making your basic semiconductors, not your advanced ones, I think last year Joe Biden put an embargo on the export of advanced chips. So why have the US done this now? Why are the US trying to stop China getting these chips? And will it work?
The reason that the US is trying to stop China getting the most advanced semiconductor chips is related to missiles, i.e. military equipment, and AI technology. So what the US is trying to do is curtail China's ability to develop its military as well as its AI capabilities. So this is why the most advanced chips are required, so that it can do the necessary calculation, which is both of these things are quite heavily reliant on. And when we're talking about military equipment, we're talking hypersonic missiles, not your conventional missiles. So these hypersonic missiles travel at very high speeds around the world, and so they need to do billions of calculations in order to avoid objects, etc.
So I think at the moment there's an embargo on all the equipment being exported to China. I mean, do you think China will eventually be able to overcome this obstacle and make the advanced ones, or do you think the US sanctions regime will probably restrict them? I suppose what I mean is the US really just kicking the can down the road, or is this a major unsurmountable obstacle?
So for China, its biggest problem is the manufacture. And as I mentioned earlier, Taiwan controls a lot of the manufacture. So the way that the US has put these sanctions is it's stopped anyone providing technology or chips to China, but that it also includes people who do manufacturing or use the machines from ASML. So it's using its allies to stop China from gaining these advanced semiconductors. So China's ability to create these in the future is dependent on how well its physicists can work out how to achieve the same technology that they are being blocked from, because unfortunately I don't think they have the necessary, even from the espionage that was in 2012, so that would have been old technology information. I don't think they have information about the latest technology.
Okay. So Nadeem, my final question to you. You are now the ruler of a country that has no semiconductor industry at all. And as we've discussed in this podcast, semiconductor is really important. So how do you go from a position of no semiconductor industry? How do you go about building one? What are the building blocks of creating such an industry?
Obviously, the first main building block of a semiconductor industry is having the knowledge within your people, whichever country we theoretically talking about. So you need to have the engineers and physicists who have knowledge of electronics, let's just say. Also, then you need to have the knowledge of architecture of chips. So this is like the design of chips, and that's just the basis of that. Then on top of that, you'd need to have like your fabrication / foundries, and these are buildings which have clean environments where it is cleaner than a hospital, and the air is filtered thousands of times before it enters the building. Because at the end of the day, producing the semiconductor takes thousands of processes and can take up to months to produce a semiconductor. And the last thing you want is to have low yield after all these processes. And we need to look at how you can build these fabrication plants. On top of that, you probably want to set yourself a strategic roadmap of what you've got, what you haven't got, and what you need to build on.
So just having the silicon material in your borders wouldn't be sufficient. There's a lot of, as you mentioned, technical knowledge and processes you need to learn and master.
That's correct. I mean, silicon in itself is the second most abundant material on the earth. So silicon is just sand or a type of sand. So it's not like any country is going to be lacking that resource, but it's more the knowledge of the physics and electronics which define the capability to build these semiconductors. And it's not only the design process is the easy part. It's actually the manufacture, and it's the complexities of how do you etch these really small 5 nanometer size transistors onto a silicon wafer or any other material which replaces silicon in the future.
So Nadeem, my final question, it really is the final question this time. Where do you see this industry going? Or what do you see the long-term challenges in this industry? Do you see us moving away from semiconductors to a different type of material? What do you see the future for this industry?
So I think we're going to hit a ceiling soon with silicon chips as they are. Even now with, as I mentioned, the Moore's law, which is doubling of the number of transistors every 2 years, we're coming close to a plateau on that. And really getting anything smaller than nanometers is going to be quite difficult, and I can't see it happening. Although ASML are developing a new piece of technology, but there are also physicists looking at alternatives to silicon, which means the industry starts again, and it may use a different technology, not laser, to etch these transistors. It may do it a different way to achieve the same result. So that's where I see the industry going in the future.
So Nadeem, thanks for your time today. That's been a fascinating insight actually into semiconductors. If you want to learn more about the issues raised today, please check out our website, www.thegeopolity.com, all one word. You can also learn more about other issues by accessing our website, where you'll find comprehensive insights, analysis, articles and deep dives. I'm Adnan, and thank you for listening.